right, this next example is for you to try. I want to just make some introductory remarks and then I'll have you pause the video and try to write this up. I'm telling you to use the squeeze theorem. That's me being nice, okay, to evaluate this limit. If I hadn't told you that, how would you know to use the squeeze theorem? Well, I'm seeing that I can't just plug in 0 because it's not in the domain here, but this factor right here is nice because it's just a cosine. And I know that cosine only takes on values between -1 and 1. So that gives me a starting point for establishing my inequality. Okay. Now I mentioned at the end of the last video that the squeeze theorem does apply for one-sided limits. And here I'm asking you to evaluate a one-sided limit. This is telling you that x is a negative number. So when you multiply through by x, you want to think about what that does to your inequalities. Okay, with that said, I want you to try to write up using the squeeze theorem to evaluate this limit. And this is partly just getting you familiar with the squeeze theorem, but it's largely an exercise in actually doing the formal write-up. You don't want to just think things and then say the answer is this, because that's not showing your work. So largely this is a question about how do you show your work when you're using the squeeze theorem. So pause the video and give that a shot, but I do encourage you to then turn the video back on and work through the explanation with me so that you can make sure that you didn't leave any parts out of your write-up. Okay, go ahead. Okay, like I said, this piece is my problem piece because that's the piece where the limit doesn't exist. But I know it's a nice problem to have because it's contained between -1 and 1. Cosine of anything is always between -1 and 1. Okay. Now, what I want to have in the middle is this function. So I can see I want to multiply through by x. Okay. X is going to be less than 0 because I'm going to be using that to evaluate this one-sided limit. So I do want to make a note that x is less than 0 for the work that I'm doing at this point. Okay. So if I multiply through by x being a negative number, I'm going to get -x greater than or equal to x times cosine of 1 over x squared greater than or equal to x. Because I multiplied through by a negative, the inequality signs got reversed. Okay. Now sometimes people want to say, well, because x is a negative number, shouldn't I multiply through by -x? No. If x is a negative number, -x would be a positive number. I didn't want to multiply through by that. Okay. So the fact that x is negative does not mean that you're writing an additional negative sign. -1 times x is going to have one negative sign in it. Now, this is actually representing a positive number because it's the opposite of a negative number. And this is actually representing a negative number because we said that x was negative. If you throw in another negative sign, you're reversing the signs of things. You're changing everything. Okay. Now, this is fun. My function is trapped in between two other functions. Okay. If I wanted to, I could rewrite it with x less than or equal to x cosine 1 over x squared less than or equal to -x, so that I'm using less than signs, but it's not necessary to do that. It's totally fine to have your inequality. If it's a sandwich inequality, the important thing is that the middle function is trapped in between two others. Doesn't matter whether you work your way from the biggest one to the smallest or from the smallest to the biggest. Okay, excellent. So now, let's take a look at the limits of these outermost functions. So the limit as x goes to 0 from the left of -x. Since I'm trying to do a one-sided limit here, I want to be consistent. All my limits are going to be one-sided. This is just the opposite of 0, which is 0. The limit as x goes to 0 from the left of this function of x is just 0. Oh my goodness, those are the same. Okay. So, I've now got my two hypotheses. I've got the inequality, and I've got that the limit of the outer functions exists and is the same finite number. So then I can say by the squeeze theorem, the limit as x goes to 0 from the left of x cosine 1 over x squared is also equal to 0. Okay. Now, if I wanted to evaluate a two-sided limit for this function, I could, and we're just about halfway there. To evaluate this as a two-sided limit, I would have to evaluate both one-sided limits. Because here I was multiplying through by x and it reversed the inequalities. If x represented a positive number, multiplying through by x would not reverse the inequalities. So I'd still have cosine of 1 over x squared being trapped between x and negative x, but I wouldn't be able to describe it consistently with one inequality. I get a different inequality when x is negative than I do when x is positive. Okay, and that's perfectly fine. That can happen, but that just means if I can't describe what happens on both sides with one inequality, I would have to look at the one-sided limits. And so evaluating the two-sided limit here would basically be use the squeeze theorem for the limit from the left, use the squeeze theorem for the limit from the right. Those will both be the same, and then you've got your two-sided limit.